Hi, 8th grade. I'm going to go over a couple of things in the functions packet that I gave to you. Today, you have today, tomorrow, and Friday to finish it up. But I thought we could maybe talk about a few of them so you understand the expectation. All right, so let's look at the first page. So I'm going to go through and do one of these as a full example. By now, you should kind of have down that domain refers to x values and range refers to y values. So all that really is, it's like the inputs. So what are the domain is all of the inputs or all of the x values that work for the situation, and then range is all of the y value inputs or the outputs basically. So all of the y value outputs that work for the situation. So when I input an x value, I get out a y value. Domain is the x, range is the y. If I'm looking at each one of these, so my ordered pairs here, -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Every single x value here, because you don't have any other information. I don't know what the function rule is. I don't have an equation for the situation. So here, all I'm going to do is when I'm asked about the domain, I can think to myself, these are the x values. And those x values are going to be -3, and I put a little one of these little brackets here just to show that it's a set. It's a set of values. So -3, -2, 1, and 3. You'll notice that -3 shows up 2 times here, so I don't have to put it down 2 times. I only have to put it down once. And then my range is going to be the set of y values. So I have 1, 0, 2, -4, and 5. So I'm going to put them in order using the same little brackets to show the set of values. And again, these are all the y values. The range is all the y values. So I have -4, 0, 1, 2, and 5. All right, so then I'm going to put them on the data table. All I'm going to do is I'm just going to put the ordered pairs over here. So I've got -3, 1. I've got -2, 0. I've got 1, 2, 3, -4, and -3, 5. You know, it doesn't ask you to do it here, but as I'm looking at these, as I go to fill it out, I always have going through my mind, right? If I have a domain and a range, I might be thinking to myself, is this a function? So you might have situations that come up where you have, well, and you definitely do in this packet, where you'll have to identify just by having a set of ordered pairs or a data table or the mapping or the graph, and it'll just ask, is it a function? Is it a function or not? So we're going to talk about that at the very, very end. Some of you may be looking right now and you have in your mind what it is. The mapping is new. It's very simple. All you're doing is on the left side, you're going to put the domain values. And on the right side, you'll put the range. And in here, you're just going to write down all of your domain and all of your range values. I didn't highlight over here. I'm going to highlight here. And I need to move my paper over just a little bit. I don't think I can zoom out anymore. So I'm going to keep scooching over. I think I'm good there to show you the mapping. So domain and range, I'm going to put all my values in. So domain, I have -3, I have -2, I have 1, and I have 3. And then for my range, I have -4, 0, 1, 2, and 5. And when I do the mapping, all I'm really doing is sending an arrow from the domain number, the number in the domain, the input, to whatever its output is. So if you look here, -3 maps to 1. So I'm going to have an arrow that maps to 1. -2 maps to 0. 1 maps to 2. So I'm just going to put an arrow where it maps to. And then 3 maps to -4. So that's going to come up here. And then I have another -3. So -3 not only maps to 1, but it also maps to 5. So I'm going to put the arrow there. And we're going to come back to these two things here in a second. All right, and then what does my graph look like? Well, I don't necessarily have a line, but I do have some points that I can input, and this is what this looks like. So when I do my graph, I am literally going to the data table and I'm mapping, or I'm graphing the points. So I've got -3, 1, -3, 1. I've got -2, 0, so -2, 0. I've got 1, 2. I've got 3, -4, so 1, 2, 3, 1, 2, 3, 4. And I've got -3, 5. So -3, 1, 2, 3, 5. 1, 2, 3, 4, 5 up here. All right, so let's talk a little bit about whether or not this is a function or not. And each of these situations will tell us whether it is or not. So actually, each of these 3 situations. So if I look here, I can get all 3 of them in the frame. Here. If I look here, I've already circled one of the issues here, and that is I have the same input, so -3 and -3, but they have different outputs. If this said -3, 1 and this said -3, 1, I'd be good. But because these are 2 different outputs, this is not a function. Remember, to be a function, every input has to have its own specific output. Every input must have its own output. If it has more than 2 outputs, it's not a function. I see that over here as well. So if I was just given mapping, I would be able to tell from in the domain, -3 has 2 lines coming out of it, but those 2 lines go to 2 different places. So it goes to 1 and it goes to 5. So since that is happening, it's not a function. And then let's talk about the graph, because you have not been exposed to the graphs yet. You have a little bit with the, like the f of x and looking at a graph to determine what f of x is given the x value. But if you have a whole graph, you can actually determine if it's a function or not by doing something called the vertical line test. And the vertical line test is very, very simple and just kind of a very kind of physical act where you actually take out a ruler or some sort of straight edge. And if you move your vertical line, so this blue sheet would be the vertical line. If you move across the page and across the graph on the x values, you can see that if every place that I can make a vertical line basically anywhere on this graph. If any of those vertical lines have more than 1 point on it, it does not pass the vertical line test. It's not a function. So here, what we have is on this particular vertical line, I have 2 points here. So this point and this point on the vertical line test tell me that it's not a function. Because on any vertical line within a graph, there should only be 1 point for any vertical line. So because there's 2 here, it's not a function. So that'll give you some guidance about how to fill out the rest of this page. There's more of these within the packet. Let's go to the second page really quickly. This is what you were doing, I believe, yesterday on Khan Academy. So let's take one of these. This is where the notation doesn't have to be quite as complex as what Khan was doing. So if I look at, oh, well, let's look at number 3. Number 3 is a pretty simple one. So number 3 is just a straight line, right? So it wants to know my domain. So what are all of my possible inputs given the situation, and my range, what are all of my possible outputs? If you just kind of scan when you go from domain, if you kind of scan from left to right, you can see that since this line is infinite, your domain is going to be every single x value. So as I move through, kind of space, as this moves out, every x value will be accounted for as this line goes further and further. So really, I can put here all real numbers. And that would be fine. I believe the symbolism that Khan was using was showing, there's a symbol that looks kind of like that shows that all real number, that would be all real numbers. With this one as well, all of your y values are going to be hit as well. So the line will go up and up and up, or down and down and down throughout time. So your range, all of your y values will also be hit. So you can put all real numbers. As the graph kind of moves, so let's do one more. And now this will show the kind of the notation that might be expected. If you have some sort of limit, so maybe it's all real numbers except for 0, then you can just put all real numbers, or x is not equal to 0, and then all real numbers, or you can put all real numbers not equal to 0, or something along those lines. So you don't have to be as complex in your notation as it was on Khan Academy. So number 2, let's look at number 2, because it's a pretty good one to kind of talk about what the notation might look like, and also the graph itself. So as I scan my pen here from left to right for my x values, I can see that I have an x value that starts here. So here x is equal to -3, and then it stops over here. So x is equal to +3. So if I look at this, and if I kind of, go from left to right, I can also see, that my x values basically will be anything. It has a y value between -3 and 3 as well. So there's a point on -3 and +3, but there's also y values. So this is -3, 0, this is 3, 0, but all of these x values as well, right here, they all have y values also as it goes through. So how I would write this for the x values is that I could do it 2 ways. So you might be at the point where you'll write x is greater than or equal to -3. So x is greater than or equal to -3, and x is less than or equal to 3. So that's kind of breaking apart one full symbol. So the preferred way to do this would be to write it something like this. So you've got your x in the middle, and we know that x is going to be greater than or equal to -3, but we also know that it needs to be less than or equal to 3. So you read it from x to the number, x is greater than or equal to -3, and x is less than or equal to 3. And that's what your notation would be. You can kind of stop there. So I have what my domain is. My range, on the other hand, is going to deal with the y values. So you notice you have a tippy top y value and a low bottom y value as well. So this is y equals 3 and y equals -3. And you have a bunch of y values that kind of go between those two numbers as well. So same thing here. You could write it as y has to be less than or equal to -3, and y has to be, y has to be greater than or equal to -3, or y has to be less than or equal to 3. And then that notation again to write one inequality, or as one kind of one way to express this is going to be not x this time, y. Y is greater than or equal to -3, and y is less than or equal to 3. So that will be the expectation on these 2 pages. You kind of have to look at the graph itself. If the lines kind of keep going, you kind of assume that that pattern keeps moving in the same direction. So here we have, we've got it going up and down, and then it kind of keeps moving out and out. This is more of a closed situation, so it'll look more like number 2. And then you've got a few more on the other side. So let's see really quickly. If you turn to page 4 on this, 3, 4, you don't have notation or notes up at the top, so we can do that right now. Let's see if you can see what I'm doing here. So it says, what is a function? Basically, a function states that each input, x, has exactly one output. Which would be your y, or you can think of it as f of x as well. There's some writing in here already. So given ordered pair, if x repeats, then it's not a function. If x repeats, then it's not a function. So if x repeats and with different y values, so the x can repeat itself as long as it has the same y value attached to it. So here the y values have to be different. So if the x repeats, if it has different y values, then it's not a function. And then here it says use the vertical line test. If a vertical line intersects a graph more than once, then it's not a function. So just make those little notations on this page. It's more of what you were doing. So you can look here in the coordinate pairs to see if they're functions or not. That basically here it just wants to know if it's a function or not. And then if you wouldn't mind highlighting or identifying why it's not a function. So, or is a function or is not a function. So for example, with number 3, I noticed that I have -3, -1, and -3, 2. So here is where I would state this is not a function because I have one input with 2 completely different outputs. And that's what you're going to do here. Let me just scan through this a little bit more. I think that is pretty much it. Let's look at the last page really quickly. This will be the last thing I go over for you for this. And then, so here you have given the domain. I'm on page 9 right now. These are only 6 problems. So the domain is, these are the x values, right? So given the domain, what is the range? You are literally going to have to plug these x values in to determine what the range is. So here I would plug, and I would show my work, but I would plug 4 in here, and I would get 4 minus 5 equals 1, so I know that 1 is part of my range. And 4 minus 5 is not 1. 4 minus 5 is -1. So -1 would be part of my range. So you're going to do that with each one of these. So you're literally inputting the x values. That, I think, wraps it up. I will talk to you guys tomorrow. We're going to attempt a Google Meet. Google Hangout, Google Meet, and if you have any questions, then they can be presented there after I give my little spiel. Other than that, you have 3 days to get this done. I will see you tomorrow. Bye-bye.